Hello everyone, today I'm gonna teach you how to implement fast and easily the Prim's algorithm. First things first, what is the Prim's algorithm? It is a minimum spanning tree algorithm, which means it is a minimum way of connecting a weighted, undirected graph without cycles, and it's also a greedy algorithm, which means it makes a locally optimal choice at each stage with the intent of finding a global optimum. Now let's see an example. We have a weighted, undirected graph with 7 nodes. First, we create an array named visited, in which we place all the nodes that we have visited so far. To start the algorithm, just pick a random node. Let's start from A. Now add this node to the visited list. Give it also a color of your choice to mark it as visited. I will give it here the color of red. Now check all the edges from this node. Choose the one that connects to an unvisited node and has the smallest weight. Remember to avoid cycles. The first edge that we choose here is the AG, which has the weight of 1. Now add the new node to the visited list and give it the chosen edge the same color as the first node. You know that way that you have already visited this node and this edge. Now we have an array visited with A and G inside it, and the edges that we have so far is the AG with a weight of 1. Now check all the edges that connect the already visited nodes except the colored one between them. Choose the smallest edge. If you have 2 or more with the same number, choose the one you want. Remember always to avoid cycles. Then add a new node to the visited list. Now repeat the same steps until you have your tree. Check all the edges that connect to your visited nodes with the unvisited nodes. Choose the smallest edge. If you have 2 or more with the same number, choose the one that you want, as we stated also before, and remember to avoid the cycles. Then add the new node to the visited list, and so on. Now repeat the same schema, each time picking the smallest edge that connects to the unvisited node until we have a tree that includes all the nodes. We can see it visually here. So now all the visited nodes and the red edges form your tree. You can find the edge weight by adding the edges weight. In our example, the total edge weight would be 1 plus 2 plus 3 plus 3 plus 6 plus 5, a total of 20. Let's see the time complexity of a Prim's algorithm. It depends on the data structures you use at your algorithm. For example, for adjacency matrix, we have a big O n to the power of 2, and binary heap and adjacency list, we have a big O n logarithmus n. Thank you all for watching.